Okay, I'm Frank Barnes, and I'd like to get us started, and since we're not running ahead of schedule, I will go rather quickly, and I'd like to introduce Om Gandhi. He's been a professor in electrical engineering for a long time at the University of Utah. He's been active in this business of modeling and developing various models for effects of both low-frequency and high-frequency radiation on the human body for many, many years. Om?
Thank you, Frank. And thank you, Deborah, for asking me to come down here. It's a good opportunity for me. Okay, I would like to summarize the main results of several peer-reviewed publications that have looked at the effect of head size, including thinner and thicker pinnas, which is the outer ear, skin and skull on the peak, radio frequency absorption for 1 and 10 gram tissues. We also compare, because these, these standards are set in terms of 1 and 10 gram tissues. Both the IEEE is in terms of 1 gram tissue, and ICNIRP, working with the World Health Organization, is in terms of 10 gram tissues. We also compare peak 1 and 10 gram SARs obtained for anatomic head models with those for the so-called SAM model, specific anthropomorphic mannequin head model, which is being used for testing, compliance testing of cell phones. So that's the model that is used, and I'll briefly talk about the so-called SAM model. And SAM model is also advised as a standard to use by the IEEE Standards Coordinating Committee. These are some of the publications in this area, peer-reviewed journal articles, that I'll be getting the data out of. One of these very recently in 2004, another one. It's a very extensive study done by us in 2002, another one in 2002, and lastly the original article that got me into so much trouble, 1996, that I've been trying to live down. So in spite of, I started working in this area in 1973, but this is the article finally that the industry said, thou shalt not publish. But I'm a professor. I'm a professor, so I don't listen to anybody other than my students. So anyway, these are the publications by others that confirm our published results of greater absorption of electromagnetic radiation into children's heads. And I quote a few sentences out of that. Joviart at France Telecom, 1 gram SAR of brain tissues of children is about 2 times higher than adults. What else is new? That's what I had said in 1996. 1 gram SAR for children is about 60% higher, and I think Alvaro is here, Dr. DeSalis, and Martinez-Bordalo. Incidentally, I don't know some of these guys. Martinez-Bordalo I do not know. As head size decreases, the percentage of energy absorbed in the brain increases, so higher SAR in children's brains can be expected. And Wang and Fujiwara, back in 2003, they sort of muddled it up. They said if you take current as a issue, then there's no higher absorption in the children's head. If you take power, considerable increase in children's heads when we fix the output power of radiation. Anyway, I'm going to present some highlights of the study that we had reported back in 2002. And we examined the effect of head size and thickness of pinna, because people have different thicknesses of the outer ear, and no two individuals have the same head size. So we looked at the anatomy book, and they said this is within the range of the sizes that you can encounter, plus 11% larger and minus 9.1% smaller of the average. So we took 3 models then to cover all grounds: larger head model, medium head model, smaller head model for adults. And the smaller head models, of course, are approach than, even though valid for adults, are starting to approach the head sizes for children. We also tagged on to these head models, these 3 head models, different sizes of peanuts, all the way from 6 millimeter, 10, 14, and 20 millimeters, to correspond to the various individuals as well as thinner peanuts of children. Different sizes, tilt angles of cell phone antennas, since you hold sometimes like that, sometimes like that, and 2 types of antennas, 3 sizes of handsets, because handsets come in different sizes, and 2 frequencies, 1900 megahertz and 835 megahertz. And these results were published in 2002 and 2004. The 2 head models are graphed here. This is the Utah head model that we have used for a number of years, developed on the basis of MRI scans of a graduate student working at the University of Utah, and the visible man model, which is for a much heavier individual. As I recall, it's 200 plus pounds, over 200-pound individual, for which the National Library of Medicine has developed cross-sectional diagrams. So we have reported this, and I'm quoting this from this paper, different head size, handset dimensions, smaller handsets, 82 millimeter large, 122 millimeter large, different antenna sizes. This is a helical antenna, which is 2 centimeters. Different models, Utah model, visible man model, so on, and all at 1900 megahertz at the maximum, at that point, maximum allowed power output, time average power output of 125 milliwatts. Note that for the brain, the SAR increases as you go from larger head model from 0.22 to 0.45 watts per kilogram. And for, yeah, thank you very much. I think battery ran out here. And same here, from 1.16 to 1.61, smaller head sizes. Body tissue values also increase monotonically. Body tissue simply means that you don't discriminate between pinna and the bone and the scalp and so on, whereas this is just the highest SAR in the brain. At 835 megahertz, all numbers normalize to the maximum allowed radiated power of 600 milliwatts. Once again, quoting from this article. Note that the peak 1 gram SARs, that is what FCC requires, for both the body tissue and the brain increase monotonically with the reducing head size and pinna thickness. For both of the head models, that is Utah and visible man model, all headset dimensions that we had assumed, and the antennas, that's monopoles as well as helices. This is the depth of penetration drawn on the same scale, and we only show half of the brain. And it's see, it's not drawn down to low values, but up to 0.03. And half of the brain, this is the larger head size model, this is the average head size model, and the smallest head size model of the adults. Same sort of thing at 835. The smaller the model, the deeper the penetration. These figures calculated for the human heads of various sizes are consistent with the results reported for head models of adults and children back in 1996, in that there is a deeper penetration of absorbed energy for the smaller heads compared to that for the larger heads, both at 1900 and 835 megahertz. Then we started to study the effect of the pinna thickness, because people do have different thicknesses of the outer ear, some as thin as 6 millimeter and then up to 20 millimeters, particularly the individuals who have bent ears. And same sort of thing there. See, the thicker the ear pinna, the smaller the SAR in the brain, and the thinner the pinna, the larger the SAR in the brain. This, to some extent, this also applies to children who are growing and therefore may have thinner pinnas.